Hey guys, welcome back to Math Savvy. Today we are going to be doing some calculus. We are going to review the first part of calculus, and this is going to be a practice exam. Shout out to Notre Dame University. I am just using one of their practice exams, giving credit where credit is due, you know what I mean? So these are not my questions. And yes, it is highly requested that we do ASMR, soft spoken. So let's begin. I have 13 questions for you, and hopefully you get some relaxation and we learn, Okay, we're gonna find this limit as x goes to 1 from the right side. And it is a fraction here. So I'm just gonna write it out. That's kind of a weird looking squared. So we see if we plug in 1 in the denominator, not the denominator, we are going to get a 0 in the denominator, which we can never have. That is rule number 1 of calculus and, rule number 1 of the world. So we have a second degree variable here. So let's try and cancel out some stuff here. So I'm gonna factor 1 minus x squared is gonna be 1 plus x. And then we have 1 minus x on the top. Then the bottom, it is x minus 1 squared. So we don't have anything that we can cancel out, but we have something that we can almost cancel out. And we're going to manipulate it as we do, manipulation. So that becomes 1 plus x. We're going to add a negative in front, and we're going to get x minus 1. And we get x minus 1 on the bottom, squared. Let's cancel out 1. So the limit as x goes to 1 from the positive side of 1 minus x squared over that is gonna be, who are those dogs? Control yourselves. It's gonna be the same thing as the limit of minus 1 plus x. Oh, that's not a squared. Anyways, that. Alright. So, can't do anything else here. So let's just estimate. So if we're going to plug in 1, on the top we get minus 1 plus, let's plug in 1, we're going to get 0. Oh wait, no, we don't get 0. Sorry, my bad. If we plug in 1, we're gonna get 1 plus 1 over 0. So we get minus 2, even if it's 1 coming from the right side. So we know that when 0 is in the denominator and we are approximating a limit, that means that anything compared to 0 on top is going to be infinity. So we have a negative on top, negative 2 over 0, or even negative 2 over 0.1111, because we can approximate right now. That's going to be negative infinity. So that is our answer. Period. Good job. So, yes, there was some estimation there, but that's allowed because it is multiple choice and it is the right answer, okay? So let's move on. Number 2. For what value a is the function f given by that f of t continuous everywhere? So say we just have the top part. So if we just have the top part, it cannot be continuous everywhere because of the denominator. The denominator is 0 when t equals 0. So we can never have that. So to ensure that it is continuous everywhere, we want the function, say that's where it's 0, that is undefined right there. We want the function to, we want this to be a, where this function is f of t. So what do we want to do? We want to find a, which is the limit as t approaches 0 of f of t. Let's do green. Okay, so let's find that limit. Okay, so of all over t squared. Great, and usually when we have something like this, we just want to get rid of the square root ASAP. And when I say ASAP, I mean ASAP. So let us just focus on this part. But let's ignore the limit part for now. So let's multiply by the conjugate to get rid of it. So we get 4 plus t squared over or under the square root plus 2 to eliminate the square root in the numerator and hope for the best. See if any t cancels out. Great, so let's simplify that. We get 4 plus t squared. Let's FOIL it, so the top is going to be the first 4 plus t squared minus 2 square root of 4 plus t squared plus 2 times the square root of 4 plus t squared. Cancel that out, minus 4. Wow, that's pretty beautiful. Then we have t squared times, what was that? 4 plus t squared plus 2. The 4's cancel out here. We get that t squared. The t squared cancels out with that t squared. So this is what we ended up with. Boom. Okay. So now that we did that side work, let's see where we get. Let's plug in the 0 here. So we get limit as t goes to 0 for 1 over So I'm just going to plug in 0 here. We get 1/4. Boom. Period. Compute the derivative of sine x plus x over 2 plus cosine x. And compute the derivative. Well, I can see something like the quotient rule. Popping in, you know what I mean? So I have to remind myself. So it is d top, d bottom, or d top times bottom minus d bottom d top times bottom minus d bottom times top over the bottom squared. And you already know that. I just have to remind myself that. So let's just do it, my friends. Okay, let's do the derivative of the top. Okay, we're finding the derivative of this. And we're gonna work in, no, green, duh. Okay, d top, that's gonna be cosine x plus 1 times the bottom minus derivative of the bottom, which is just going to be minus sine x times the top, which is sine x plus x. I'm just going to add this so far. This is a multiplication. So far it's looking like this one is the right answer, but let me, there we go. And then the bottom squared is 2 plus cosine x squared, period. And that makes sense. Thank you. Next. Okay. If f prime of 2 equals 5, g of 4 equals 2, blah 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 blah. Find the derivative of this. So to remind myself, d of dx. And you know what? Calculus is all about the time and effort that you put in. You have to remember these rules. We're just gonna say f(x) for now. You have to remember these rules. These are essentials. So this is the chain rule here. Then if we're doing 4, we're going to do f prime of g of 4 times g prime of 4. What is g of 4? It is 2 times g prime of 4 is 3. F prime of 2 is 5. We get 5 times 3 equals 15. Duh. Period. Thank you. Next. Number 5. Compute this limit. Oh, this looks kind of silly. obviously sine of 0 is equal to 0. So I'm just going to play with this for a second. And I only know this because I've seen a problem like this before. So these types of things are not very intuitive unless you practice a lot. So this is how I would do it. So this gives you the opportunity to find this derivative, and this derivative. So, or not that derivative, that limit. You know what I mean. So the limit as x goes to 0 for this, by using something called L'Hopital's rule. You know that. You already know that. Honestly, L'Hopital's rule, so good, you know. How does it make sense? But it does. So sine of 7x over 7x. Let's take the derivative of that. L'Hopital's rule says that if you take the derivative of a function, the limit of that function is same as the limit of the original function. Okay? So the derivative here is 7 cosine of 7x because of that chain rule over 7. These 7's cancel out. If you plug in the 0 for the cosine, that's 1. Similarly, the second one, 7 over 5 for L'Hopital rule. And similarly, we get 5 over 5 sine 5x, or 5 cosine. Cancel out that 5, that cosine, when you plug in the 0, is 1. So 7/5. It's an answer. Alright. If the cost function for producing X items is given by C of X dollars, then the marginal cost at that production level of 50 units is... Okay, so when you see the word marginal, we see this in economics, we see this in other subjects. When you see that word, that's gonna signify a derivative is involved. A derivative or a rate of change is involved. So the marginal cost is going to be the derivative of the cost function. So marginal cost is going to be C prime of X. So the marginal cost at the production level of 50 units is where 50 is the X value. So what we're doing is really just taking C prime of 50. So let's do it. First, let's find C prime of X. Which, here we go, we get 2 plus 2 times 0.1 X. We get 2 plus 0.2 X. Plug in 50. We get 2 plus 0.2 times 50 is 10. We get 12. Period. That's beautiful, right? On to the next. I'll write the equation of the tangent line to y equals sine x squared plus 1 at this point is, let's find out. So we know that the tangent line is going to be the slope of the function at a given point. In other words, the tangent line is going to be a derivative at a particular point, but you already know this, you know? So let's do it. We have y equals sine of x squared plus 1. We're going to take the derivative of that. That is the function. So let's do it. We're gonna do cosine of x squared. But the chain rule tells us that we have to have that 2x in front. The derivative of 1 is 0, so we can ignore that. Plugging in the x value at the particular point, we get cosine of root pi over 2 squared times 2 of pi over 2. Cosine of root pi over 2 squared is, they're just going to cancel each other out. We get cosine of pi over 2, which is 0. And then this becomes irrelevant suddenly. So we know that the slope at this point is 0. Now, all we need to know is what is the value of the tangent line. So the answer is going to be, if the slope's 0, that means it is a horizontal line, it is only a y value. So it is going to be this one, because the y value at this point is 2. Another way, if you want to approach this in a more logical way, we can look at this point slope form, which is, we're going to use a different color here, y minus y0 equals the slope of x minus x0. When the slope is 0, we get y, this becomes irrelevant. We get y minus, what is the y value, is 2. We get y equals 2. The y value is the point that we're looking at here. Great. On to the next. Okay. Find the derivative of f of x equals 2 plus x, whatever, to the fourth, to the 2/3 power. F prime is what we're trying to find. We got this. We just have to use the rules that we already know. Okay, so we take 2 plus x4 to the 4th. We're going to do 2/3 minus 1, and then we're going to times that by the derivative of what's inside the parentheses, which is 4x cubed. Simplifying, we get 2 plus x to the 4th of minus 1/3 times 4x cubed. And you know what? I forgot to put the 2/3 in front. So I'm going to do that. 2/3 is in front. And then period. It would be this one because it has the right sign here. X cubed. We have that. Yeah, it's choice D. Okay, only a couple more. So these are the open-ended questions. No more multiple choice. That's fine. You can do that. Find the derivative of y equals 1 over 2x minus 1 using the definition of the derivative. Okay. Definition of the derivative is this is just something that you have to know. So knowing that, we are going to do it. So this is equal to f of x. So f prime of x is equal to 1 over 2 x plus h minus 1 minus 1 over 2x minus 1 all over h. We are going to combine these. So I'm just going to put the 1 h in front. I have 1 over 2x plus h minus 1. We're going to multiply that by 2x minus 1 or 2x minus 1 subtracted by times 2 Okay, let's write this out. The bottom, the fractions become 1. So we have 1 over h times 2x minus 1 minus 2 of x plus h minus 1. And that becomes a plus 1 because of this negative sign. And then the bottom we get 2x plus h minus 1 times 2x minus 1. And then we have things that cancel out, don't we? These ones cancel out. If we distribute the x here, we get this canceling out as well. So boom, boom. And we end up with 1 over h times minus 2h over all of this. Excuse my bad handwriting. I'm sorry. I'm not perfect. But you get the idea, right? Okay. Now those h's cancel out. And we get minus 2 over 2 x plus h plus 2x minus 1. Or no, that's times. See, this is why we have to pay attention. Okay. So what do we do there? Of course, what we're trying to do is find the limit here. So the limit as h goes to 0 of this we just need to plug it in. Plugging in 0, we get 2x minus 1 times 2x minus 1, and we get minus 2 over 2x minus 1 squared. If we found the derivative the standard way, what would we get? Minus 2x minus 1 to the minus 2 power times the chain rule, which would be times 2. And that's exactly what we got. So, period. Let's move on. We have 3 more questions, you guys. Let's do it. Okay, so show that the equation has at least 2 solutions. Identify the theorem you use. Okay. Okay. So let's just write this out. Okay, so my first thoughts are that we're going to use that. There's only a couple theorems in this course. It would be the fundamental theorem of calculus and the intermediate value theorem. So, and there's a couple of rules, but these are the major theorems. And the mean value theorem as well, but here we're using the intermediate value theorem. And what that says is that if you have a function with 2 points, call this A and B, and then this is f of A, f of B, then every point in between them in the A and B provided that this is a continuous function, every point is going to be included here. So every point, so for, let me explain this better. For all points within the A and B, for all x values in between these 2 points, then they're all going to be included along with all of the y values. It has to hit the function has to hit every y value in between, the infinite amount of values in between there. It's all going to be included in this function. For some x or another, it has to be part of it. So anyways, we're moving on there. So let's just plug in values here. I'm gonna just do, let's do, provided that this is f of x. So I'm gonna do -1, 0, and 1 for now. That's usually what everyone does. That's what all the cool kids do. So -1 to the 4th plus 2 to the -1 cubed minus 2 is -1 to the 4th is 1, -2 minus 2. That's -3. We plug in 0, we get -2. We get 0 cubed, blah, 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 0 cubed, 0 cool with the 4 power. What is that? What? It doesn't matter. Okay, and then we have x. We have 1 to the 4th plus 2 times 1 to the 3rd minus 2, which is 1 plus 2 minus 2 is equal to 1. Okay. So we know that through the, this is important here, through the HEYYY, which is the intermediate value theorem, there must be one solution. Let's just call it M, such that f of m equals 0, which is, this is f. So that's one solution. Let's find another one. Maybe let's try -3. Oh, you guys. This sounds like a hassle if you ask me. But yeah, let's do -3. -3 to the 4th power is 3 times 3 times 3 times 3 minus 81. Oh, sorry. Minus 81 plus 2 times 27. It's not minus 81. It's positive 81. And 2 times 27. Negative 27. Minus 2. 81 plus 2, or 81 minus 2 times 27 is 54. Minus 2, which is equal to, it's like 1 in the morning. It's 1:30 in the morning. 25. Okay, that works. 25. Is that right? 56. Okay, doesn't matter. All we know is that it's positive here. So, if it's positive, that means it goes from the -3 at the, goes from the -1. Okay, if it's positive, which it is, the value of f at -3 is 25. We get, when x goes from -3 to -1, it goes from positive to negative. Therefore, the intermediate value theorem, by the same logic, tells us that it passes through 0. So there must be at least one solution between -1 and -3. So what we found is, let's move on. So through that, there must be one solution m such that f of m equals 0. There must be two solutions. And we know exactly where they are, but we're not going to tell you what they are because ain't nobody got time for that. So we know that there's one solution and then we have, it's in between 0 and 1 as well. It's not equal though. Excuse my silly mistake, my guys. So this is where the x values are. Period. What else do you want from me? 2 more. Okay, we got this. If a ball is thrown vertically upward with a velocity of 64 feet per second, then the distance is traveled is given by this. Okay, so you have a distance, and you have a distance function. Take the derivative, you get the velocity. Take the derivative, you get the acceleration. That's just the fact of the matter, you guys. That's the facts of the facts. Argue me. Prove me wrong. You can't. You won't be able to. Okay. What is the velocity after 1 second? Oh my gosh, you guys. We know exactly what to do. So we take this distance function, take that derivative, plug in the time. T equals 1. 64 minus 32 is equal to 32. You guys, that's the feet per second. Part A, complete. Part B. This is just silly. When will the ball stop going upwards? That is, when will the velocity be 0? So when 64 minus 32t, which is what the velocity function was that we just found, I should have kept that written, when that equals 0. So doing algebra, we get that t equals 2. And what is the maximum height this ball can reach? We know literally through the laws of the universe, we're throwing a ball. true. Once it hits that point, we know that point is t equals 2. It's the maximum height. Once it stops moving, it'll stop for a second. Then it's going to come down. And when it comes down, that means it's already reached its max height. Physics, you guys. Physics. So, what is the maximum height? We literally just plug it in to the distance function. So we can find the distance. We get you know what? I've been doing these silly things for years now. They tend to ask all the same questions, you guys. They tend to ask all the same questions. And I think that's okay. This stuff requires practice. And you know what? I realize that this doesn't cover all of calculus, so I might have to remake another video if we get a good response from this one. Covering a whole final exam. Although, this is good for a first exam. You got this. Okay, draw the graph of a continuous function with f of 0 equals 3. And all of that. You guys, okay, f of 0 is equal to 3. That means the y-intercept is 3 here. I'm going to use another color. F of 0 is equal to 3. F prime of 0 is equal to -1, so it's going to be passing through like that. F prime of 2 is 0. So we have a 2. It's gonna go like that because we already know that it's going down. And f prime of -2 is 2. So we have -2. We know that this is gonna be like more like this. That is an acceptable answer. And that completes my calculus exam for you. I hope you enjoyed this, and I hope that you learned something. I hope this helped. I hope that you pass your exam, or you have just, gained some knowledge, gained some practice, I hope you have the best night of your life or the best day of your life, and I'll see you next time. Peace, love, Unicircle.